brown bag on browser ID and privacy. And before I get to introducing Ben and we get started, I just wanted to make a couple quick announcements of some things that are happening here on privacy at Mozilla. In particular, we're working with Disconnect.me, who is about to launch a crowdsourcing effort around privacy icons that Mozilla and the Mozilla community put together as a drumbeat project. And so that should be, so it's live at disconnect.me/db. And so for all privacy professionals here, it's definitely something, be an interesting experiment to see kind of how the community views privacy policies on websites and how we can attach icons to explain what's happening with those privacy policies and the data practices of those sites. The other thing I wanted to just make a quick comment on is, I don't know if some of you saw the study that was published today about the adoption of Do Not Track out in the wilds of the web. And I just wanted to sort of say, from our perspective, we are also tracking that user adoption and can confirm that the number is about where the study placed it, which I think was about 6% of Firefox users today have turned on the Do Not Track header. We actually will be publishing our numbers very soon, along with an implementation guide that we've written for website developers. And part of creating the Do Not Track header was an important step for us within the browser and Firefox. But we also feel very strongly that we have to also provide tools and techniques and approaches for websites in terms of how they respect a growing number of users who are asking to not be tracked online. So I just wanted to put a plug in for that since the news was kind of timely, but there'll be more announcements in the coming weeks from us on that. And now to the program today. BrowserID and privacy. I'm just going to turn it over to you, Ben. Ben Medina is our tech lead for identity at Mozilla. And
all right,
the floor is yours.
Sure. And put all these extraneous mics away. So this is a brown bag, which means if you have your lunch, you should feel free to be here. You don't feel like you have to be hiding away. This is as informal as you'd like it to be. The way I want to structure this is I want to spend about half an hour at the most going through this presentation of BrowserID, and then leave a whole bunch of time for questions afterwards. If you have spot questions, like something I say doesn't make sense or the diagram doesn't make sense, please feel free to interrupt me. If you have a longer question that's more philosophical, deeper architecture and such, if you don't mind holding until the end, that would be fantastic. But if something I say doesn't make sense, yeah, we'll have a mic. Just wave your hand. Or on IRC, we have Tom monitoring IRC. In fact, I'm going to turn mine off because otherwise I'm going to get all sorts of side channel stuff here. So here we go. So I have the privilege of steering this technical ship for identity now, but this work has been going on at Mozilla for quite a long time before I joined. And there are a lot of folks that need to be given credit for all this stuff. There's a lot of efforts that have been made by Mike Hansen, Dan Mills, who really spearheaded this effort, Lloyd, who wrote most of the code for BrowserID, Shane, who recently joined the team. We've got a fantastic team here working on this stuff. And BrowserID is a little bit the culmination of 18 months of efforts to figure out what useful experiments, what useful advances we can do in web logging. We want better web logging with strong privacy protection. That's what we're trying to do. Pretty simple. We're not trying to solve all authentication problems. We're focused on the web. But we are trying to solve it in a way that's going to have strong privacy protections for most users. Not just for advanced users, for most users. And that's quite important because most users don't spend a lot of time thinking about privacy, except when it bites them. And so we'd like to set up a system that helps them do the right thing, do something they understand as they're authenticating on the web. So the vision is simple for users. That's the first thing. Oh, and just to let you know, what I'm going to do is I'm going to give you an overview of the architecture of BrowserID, how it works, where the data flows, and I'm going to pinpoint at every step of the way where we made a design decision for privacy. And the reason we want to do it that way is so that when you come out of this, hopefully you understand pretty much how all the data flows in BrowserID and what you're getting into if you choose to implement it or you choose to use it. So the vision is that it has to be simple for users. That's obvious. If users don't understand it, they're just not going to use it, and the sites won't implement it. It also has to be simple for developers. Developers meaning the folks who implement this on their websites, who allow users to log in using BrowserID on their website. If it's too complicated for them, they're probably going to pick a simpler solution that may not have the same privacy protections we need. So we want it to be simple for developers too. We want strong support from multiple personas for users. This is an important part of the Mozilla mission. It's about user choice. It's about user control. Users have different facets to their lives. They should be able to log in to some sites with one aspect of their personality and to another site with a different aspect. That has to be a core feature of the system. Decentralized, so that there's no dedicated, they're in one or a few privileged providers of identity. And no lock-in, which turns out to be a little bit different, actually. Because you can imagine a system where lots of folks can provide identity assertions. Lots of folks can certify that you are who you say you are, but you can never move off the infrastructure that's been built to enable this kind of system. So we want to be both decentralized, and if people want to bail out of BrowserID in the future, they should have that ability. They're going to use BrowserID because they want to, not because they got tricked into using it and then they're stuck. And privacy protecting at every step. What that means is, at every step of the protocol, we're going to say, is this information transfer leakage necessary? Or can we build a protocol that reduces the amount of information that leaks in various ways? Okay, so players. A lot of folks in the audience have been doing this stuff longer than I have, so I'm going to rehash a few things. I won't spend too long on terminology. In the world of online login, you have identity providers, companies or small groups of people who give you a username within their scope. That can be as large as Google, giving you a username, a Gmail address. It can be as small as a small company, giving its employees some credentials and saying you are a member of this company. It can be ISPs, it can be email providers. A bunch of organizations that basically say, within this domain, you are this user. So those are the identity providers. And you have relying parties. Those are websites that provide functionality, things like content, CNN.com, stores, where you can buy stuff, photo sharing, etc. All of the features that you use on the web that are not primarily about giving you an identity, but that probably use a different identity that you have. Maybe it's as simple as asking for your email address to log you in. Maybe they let you log in with your Google account. But at the end of the day, they're not really the ones providing the user account. They're the ones letting you do stuff with your account. And of course, the user and their browser. So the first step is to realize that we think the browser is going to play a very important role in federating the identity from the provider to the relying party. And the reason we think it plays an important role is because if it doesn't, if we use browsers as they currently are, meaning mostly just rendering the content that is given to them, then what happens is that at the time that you log in, when you go to that photo sharing site to look at the latest photos from your family, then we don't really know how to do that without involving the identity provider at the time of login with current browsers. So the analogy, maybe that doesn't sound so bad, so I'll give you an analogy. When you check into a hotel, you usually have to provide some kind of photo ID to prove that you are indeed the person on the reservation. How would you feel if the hotel called the state at that point to check that that driver's license you're showing is indeed a valid one? Every time you show your driver's license, there's a phone call made to the authority that granted that driver's license to check if that's still valid. And if they did that and you got some kind of problem with the state for whatever reason, the state potentially could say, yeah, it's invalid, for reasons completely different than the fact that you're trying to authenticate. There's lots of reasons why forcing the identity provider to be part of that login transaction is not the best approach. And the only way we can see to prevent that is to have the browser play a more active role in the transaction, effectively to replicate the seal on the driver's license so that it can be independently verified without having to give the state a call. So there's actually a lot of other reasons why it's good to have the browser involved. There are potentially a few anti-phishing measures we can take inside the browser to make it a little harder for attackers to phish your password. But the architectural reason is the one I just described. We don't want the identity provider to have to be structurally part of that login transaction. Any questions on that so far? No? Okay, awesome. All right, let me quickly move along now. Let's hit the point that may possibly be the most controversial part of this discussion. But actually, I'm going to strongly endorse it and say I don't think this is a bug. I think this is a strong feature of our system. We have users authenticating to websites with their email address. That's what BrowserID is about. It is about you proving to a website that you own an email address. Why do we think that's a good thing? Well, one, it's an identifier that's inherently distributed already. You are Johnny at identity.org. Identity.org has given you that username, and a different domain can give you any username it wants at that domain. So those tokens are inherently distributed. They're intuitive, and I can't really overstate how important that is for users. Most users already know the difference between logging into a site with their personal email or with their business email. You don't have to explain that to them. They understand that there are some sites they probably don't want to log into with their business email. And vice versa, right? If we're going to have a privacy-protecting system that applies to most users, it has to be understandable by most users. And we can't think of a better identifier that already supports the concept of multiple personas than email addresses. If you need a fresh persona because you're doing something different, maybe outside the scope of what you usually do, then you know how to do that too. You go create a throwaway email address at Gmail. Maybe it's not completely throwaway. Maybe it's an aspect of your personality you don't tell anybody about. It could be as simple as you're doing some babysitting on the side, and you don't want everybody else to know, so you set up Palo Alto Babysitter at gmail.com. That's a reasonable use case that users understand, and that explains how emails are used as personas. Pseudonyms are fairly obvious. Email aliases that can forward to you. We can build pseudonymity into the system. We can even do it in very aggressive ways where the browser can help you generate those pseudonyms. And self-hosting, if you're a user who really just doesn't want to rely on anybody else, well, we already know how to do email, self-hosted email. It's the same thing here. You can self-host your own domain, and you can provide your own identity tokens for your entire web activity. Addressable. An email address is something you can send a message to. Again, we think that's a feature, not a bug. The reason it's a feature is because almost every website wants to be able to contact you for very legitimate reasons. They want to be able to tell you, oh, we have to delete your data, or we lost your data, or something happened that needs your attention with respect to your activity on that site. That's really crucial in the relationship you set up with any website out there. So the addressability of the token is a big deal in our mind. And then linked to that is the no lock-in idea. So if we did everything, and we had a token, an identifier that was not addressable, but still distributed, had all these other properties, but you couldn't actually send it a note, then how would you break free of the system if you wanted to? How would the site take their users and say, you know what? Ben's a crazy guy. This BrowserID stuff's just not working out. I've got to move out of here. How would they do that? Well, with an email address, it's pretty obvious. They can just send a note to their users and say, for reasons X, Y, and Z, we've changed our authentication system. Click this link to migrate your account. So I'm sure there'll be plenty of questions as to that architecture choice, but at least I wanted to make clear those are the points, the reasons we think the email address is a really strong, really understandable identifier that has all the properties we want. So very quickly, because I know that not everybody has seen this, certainly not everybody has seen Haskell, but that's not what I meant. So this is a Haskell community. We didn't build this. This is somebody else. And they have this sign in via BrowserID as one of the options that they put up. And when you click, and it's worth pointing out that in their blog post on BrowserID, I think they say it over here. They say, this was super easy. Oh, it doesn't say here. It says it in a different blog post. It basically says, this was super easy. It took us 3 lines of JavaScript and 10 lines of Haskell to get this working. And that's the kind, and it's not just because Haskell is awesome, right? It's actually very simple to write the code you need to make this work. So that's the kind of stuff we think is really important for this to be a widespread deployable system. And to be able to have a widespread deployable system that has the privacy properties we've tried to build into this, that's exciting. So, sorry, let me do this again. If we log in, we click sign in via BrowserID. Oh, of course, the pop-up is over here. You get a pop-up. You get to choose among your email addresses, my personal or my business one. You click sign in, and you're done. You're in. That's it. That's the flow from the user point of view. And it's the flow from the developer point of view is, as I said, 3 lines of JavaScript, 10 lines of Haskell. Any questions so far? No? Okay. All right. So let's understand the data. Oops. Let's understand the data flow very quickly so you see what's happening. The first thing that a domain does, like identity.org, is it publishes a public key. This is straightforward digital signatures. We won't go into the crypto details except you need to know that there's a key pair, a secret key, and a public key. And you use the secret key to sign, and anyone can use the public key to verify. And based on that, you can build certificate chains that say the identity.org can sign a message saying, yes, this public key over here really is Johnny@identity.org. And then Johnny@identity.org can then sign an assertion saying, this is me logging in today, and you have a chain of certification all the way up to the domain. Straightforward certificate chains for people who know it. There's nothing wacky going on here. So you have a public key that's published at a well-known URL for that domain. You authenticate to your provider. This is you surfing the web and logging onto Gmail. This is nothing crazy, right? You just log into Gmail, and you're authenticated, and then Gmail can ask your browser to generate a key, get the public key, certify it as being bound to Johnny@identity.org, and then send you the certificate back. It gets stored in your browser, and that's it. That's how you're certified. You got a signed key that says you are Johnny@identity.org. Later, maybe that afternoon, you go to log into blogs.net where you blog. And what you do then is you sign a message that says, this is me, Johnny@identity.org, signing into this website at this time. And this is the certificate I have from identity.org that says that I'm allowed to sign this. You send that over to the blog. The blog is able to verify it, potentially retrieving the public key for that domain if it has never talked to identity.org before. And then it knows that you are indeed Johnny@identity.org. The reason it knows that is because it followed the certificate chain all the way to identity.org. That's the site that gets to assign email addresses at that domain. So it's pretty clear that they have the authority to say, this is Johnny. Okay, any questions so far? No? Yes?
Where is the domain public key published?
Where's the domain public key published? Right now we're taking at a well-known URL over SSL at that domain. But that's a detail that we're still fleshing out, so if you have suggestions on how to do that
So for now, the BrowserID.org one is hard-coded in your code?
I'll get to that point in
Okay.
just a second. Yeah. Yep. The question that I'll get to is about what about BrowserID.org? Is that hard-coded in our system? As we would comments on that. Okay, so with that flow, there's one key question you have to ask yourself. This seems like a pretty big hammer, all these crypto keys, to prove that I own an email address. Now, remember, the only reason we're using this cryptography is to be able to separate the part where you're certified from the part where you sign in. That creates the more private interaction so that your identity provider is not part of that login action. So it's the seal on the driver's license as opposed to the call to the state, right? But let's make sure that we don't give too much power via this cryptographic keys, because otherwise they could be used for lots of things that would fingerprint the user and make life a little bit less privacy happy than we like. So key duration is an interesting issue that we got a lot of feedback on actually at IIW earlier this year. And we basically decided that, okay, if we have long-lasting keys that last for a year, then we have to deal with things like revocation. What happens if you lose your device? We have to somehow revoke it. That's pretty much hell. We don't want to deal with that. We don't think we need to set up a system that has to deal with that. So that already says maybe short-lived keys is what we want.
Doesn't short-lived keys reopen the problem that your identity provider could decide they don't like you and cut you off?
Yes, so the question is, doesn't short-lived keys mean that your identity provider could cut you off? Sorry. That's true, although if that's the case in any distributed system, right? Gmail could at any time cut you off and say you don't have your account. So we haven't changed that property. It's true. They won't be able to cut you off based on a particular interaction you're doing. They can just, in general, decide you no longer own this email. It does mean you're going to be going back to your identity provider more often if you have a short key. Maybe once a day, maybe once a week. But the point is, when you do, you're just saying, hey, I want further proof that I still own this address. You're not telling the identity provider why. You're not saying, I need this key because I want to do X. And then in general, unless you really want to, binding a long-lasting key to a user, that leaks more information than we need to, right? It's potentially a cryptographic trace that people can consider non-refutable, that they can look at and say, this proves that you were here at this time. And if you're using two devices and they each have a long-lasting key, you can start to figure out patterns. Oh, they're logging in from their work machine here, they're logging in from their home machines here. There's lots of extra information leakage from using long-lasting keys that establishes patterns. And we don't need those patterns. So let's not set them up. Let's keep the keys short-lived. You can clear them at any time. All you need to do to get another key is revisit Gmail, which we can even automate at some point. You're revisiting of Gmail. Right? It's just enough to transfer the authority to you from the identity provider that you own that email address, and that's it. And it's just enough to keep the identity provider out of the login games. That's all we're trying to do. So, this is our ideal architecture. We can still talk about it, of course, but based on what I just described, this is the ideal we have. You establish with your identity provider a certificate for your ownership of an email address. You store the private keys that correspond to that in your browser. You use the certificate chain and the signature to prove to a website that you own that email address, and the website verifies the assertion. This is a beautiful, decentralized world, and it would be awesome if we could snap our fingers and be there today. But we can't. You can't just snap your fingers and set up a decentralized system. You have to provide some kind of on-ramp. You have to provide some kind of scaffolding to let people adopt the system before everybody else has. Right? So the first optimization we're doing is the introduction of secondary authorities. And this goes to the question of what do we do with the BrowserID key, right? So we cannot expect every email provider to immediately step up and be a provider of certificates for their users in this sense. That's not going to happen overnight. So what we have introduced is the notion of a secondary authority. And for now, that's us, Mozilla, but we're sure there will be a few others. We'd like to keep that number small because that's not the overall, the goal here is not to create another certificate authority structure, right? That's not what we want. This is just a patch to get us to the place where things are fully distributed. And the secondary authority is going to issue certificates that you are really Johnny at identity.org. How's it going to do that? Well, we're going to use the fact that the address you have is addressable, right? We can actually send you something. So we can send you a verification link, and if you click on it, and we confirm that that's the same web browser session, we'll say, oh, okay, yeah, that's Johnny at identity.org. we will sign that key saying it's indeed you. Excuse me. That means that the verifiers, the relying parties that are verifying these assertions, they have to choose to trust us to do that for them. We're not hardwiring it into the protocol. We're saying, you should probably trust us. If you don't trust us, then you should probably trust us to certify email addresses. That's it. If you don't, then we're not going to hit that on-ramp the way we need to. And we expect there will be others. There are already other places on the internet, Google, Facebook, and LinkedIn, who certify people as owning other email addresses they don't control. Google will do this mailback and then tell the world. They'll let you send email from any email address you want, right? So they already do this. Facebook also checks your email addresses. So does LinkedIn. A lot of these sites already do this kind of function. So that's the first optimization, the first part of the scaffolding to get to this distributed world we want. The second part is we are a browser vendor. We can move pretty quickly on implementing new APIs into the browser to support this kind of stuff. But even we need a little bit of time to ramp up. And certainly it's not that we can snap our fingers and make every other browser vendor adopt this, right? So if this only works if you're using Firefox, that's not going to fly. That's not really what we need. So what we have is we've added the notion of an implementation provider, which is a web server that ships JavaScript to your browser. It's BrowserID.org. That's the website. And that's the JavaScript that does the key generation, that stores the keys in your browser local storage, and that basically implements the API that we eventually want the browsers to implement. And that way it works across all modern browsers today. And then over time, the library we have that people include in, that relying parties include in their sites, over time, as soon as the browser implements that, the library just shuts itself off. Any questions about that? No? Okay. And then the last piece of scaffolding that we've added is one that is that's the shortest term one. It's basically we've said, there's this assertion of ownership of email address. We actually haven't finalized the format for that assertion. So if you're verifying it on your own, you're going to have to keep up with us, which is not the best approach, right? So what we've set up is a verifier service where the blog, or any relying party, can treat that assertion they're getting from the user as a black box, ship it to our verifier service, and our verifier service will come back and tell you, this is indeed this user. Okay. So at this point, if some of you are not going, then what's the point? You led us down this one path, and then you came right back to the point where every login action is checking in with the verifier service. What have we accomplished, right? This sounds like some crazy loop, and we got nowhere. And that's a fair question. I'm not delaying the answer, I'm just coughing. This is scaffolding. One way to think about it, it's not a perfect analogy, but one way to think about it is when we switched to HDTV, we couldn't do it all at once. We had to get people to buy TVs that were capable of doing HD and standard depth. And once there was enough market penetration of HDTV, then we can turn on a little bit of HD broadcasting, and then we can start upgrading the equipment, and then we can start moving all those pieces in that direction. This is a technology adoption problem. So the difference between what we're proposing, even with all the optimizations, even with all the scaffolding, is that the relying parties stay the same. They always say navigator.id.getVerifiedEmail, and they get an assertion that way. The identity providers stay the same. They always say navigator.id.registerVerifiedEmail. And we have all this scaffolding, which is centralized, to make those work. But as time goes on, as identity providers start coming up, we'll take down some of the scaffolding. And the relying parties don't need to know or change. That's the difference. Right now, it will be just as centralized as other protocols, but it will be set up for removing the centralized scaffolding and eventually ending up at the fully decentralized architecture we're talking about. because there is no way to snap our fingers and have the decentralized architecture today. But there is a way to set things up, to set up the right abstraction layers so that we can eventually get there. And that's what we're trying to do. So, in summary, we think the browser plays a crucial role for secure, privacy-protecting web login. We think email addresses are ideal identifiers. This is not something we're shying away from and saying, oh, let's sweep this under the rug, it's not the best part of the protocol. Actually, we think it's a very good part of the protocol. I'm going to point to Dan. Dan wanted me to talk about how the status quo, if we don't do this, the status quo is bad for web login. And my response to him was, I don't want to talk about it that way because I think this solution stands on its own as a very good practical solution. And email addresses are a part of that. The signatures keep the login dance private from the identity provider. That's the only thing they're meant to do. And the short-term keys reduce the fingerprinting risk because then we may have introduced when we add the cryptographic keys in the first place. And then scaffolding. There's a whole bunch of scaffolding to make sure this distributed architecture works today, right now. You can adopt it on your website. And over time, we take that scaffolding away, and we're left with what we think is the ideal web login method, which is distributed, no lock-in, multiple personas, and with strong browser support to make sure the users keep control. And that's that. So I'm sure there are a whole bunch of questions now. I won't limit the scope on them. Please ask all questions, including the hard ones. If you can wait 2 seconds for Alex to come over with the mic, that'd be great. And we could start on IRC if you want.
Yeah, we've got, I think, about 100.
Question from Alex Hamp on IRC. What about the issues this might cause for spam? If spam agents can use BrowserID and is widely incorporated across the web, it can increase comment/forum spam significantly, especially if the third-party site doesn't implement some other form of technology to verify it as a human.
Okay, so this is about, I think this question is about, if we make it email address based, then potentially robots can start creating all sorts of accounts and doing all sorts of things like that. I think that's the case today with any website that accepts email address and an email address challenge as the way to register, which is you could have a bot that does exactly this, gets the email back, clicks the link, and then has an account. Determining the difference between a machine and a human should be done with a CAPTCHA or something like that, probably in addition to BrowserID. And it doesn't even really make sense for us to integrate a CAPTCHA into BrowserID to certify that it's a human, because then rogue domains will obviously certify their robots as humans. So I think that is orthogonal. Any other questions?
To what extent are we going to try to protect the email address from like man-in-the-middle observers? Like, are we going to require the relying parties to implement SSL for the connection that receives the assertion?
That's a great question. So the question has to do with the... I'll rephrase it to something that I think is related that I like, which is, can we use this to make relying parties adopt better security practices to protect the users? I think the answer is probably yes, at least by giving indicators in the BrowserID pop-up about the site, the last time you used it, whether it's secure or not, and providing more indicators about it. With the caveat that we know that indicators are only somewhat useful, but at least we can play with them in a very powerful way, because we have that whole dashboard to think about. As to whether we force relying parties to do SSL or things like that, I can imagine that certain personas can be tagged such that they can only be used with relying parties over SSL. And having different level of assurances and different level of required protection for the entire transaction seems like it's worth exploring. We haven't done anything yet in that respect, but I think it's doable.
Other questions? Hey Ben, so the question I have is, how strong are your feelings that that identifier user ad server has to be an email address versus something that can be looked up at a 1-1 URL?
Great, that's a great question. So how much do I love SMTP, I think is your question. This much, right? We certainly think that there are avenues for messaging other than over SMTP. We think it's really important that there is a universal approach already for these identifiers to be messaged. But certainly if we have ways of declaring via discovery, whether it's WebFinger or otherwise, that there are other ways of messaging this user, I think we're all for that, absolutely. The universal fallback is important to SMTP, but that doesn't have to be, the limit of what we do either.
Hey Ben, how short-lived are the keys, and how did you come up with that number?
We don't know yet, so we haven't come up with that number. The general idea is that we feel that if this is your regular identity providers that you're using and you're constantly logged into Gmail, for example, then we can make them pretty short-lived and safely. Right? So we're discussing things on the order of a day or some, maybe even less, but that's kind of the range we're talking about, but we haven't finalized the discussion. Back to the IRC.
Alex Hemp has a follow-up that that currently robots have to prove that they're human for every site they visit, but only once for browser ID.
I don't think that's right. I think, maybe I didn't express my answer before correctly. I think if the website is worried about a user being a robot, they have to do the Turing test, right? They have to do the CAPTCHA. I don't think browser ID can do it. Maybe I misunderstand the question.
Hang on a second.
Even if they don't trust all identity providers to make human assertions, they might trust Gmail and Yahoo to make those assertions.
That's true. That's true.
And it would be nice to not have to enter a CAPTCHA on every site that I want to.
That's a good point. So I think you're saying we can even do better, which is we can build in the notion that certain identity providers will be trusted not to certify bots, and then we're in good shape. How we make that scale to the fully decentralized web is an interesting question, but maybe it's just a universal question of who you trust and the story. And certain providers will trust certain identity providers, and we can't magically invent trust for the internet.
Actually, it probably falls within the level of assurance issue that you raised before that still needs to be addressed, but that could become an aspect of level of assurance for an IDP.
That's a really good point. Yeah, we have had some discussions about certain identity providers being able to make assertions that are somehow legally binding as to the kinds of checks they do on users, but we haven't gotten very far down that path. We like the fact that these things seem very tractable once we have this architecture, that there is, it seems to be a natural path for these higher level assurances, higher assurance levels to be reached. Yeah. I guess IRC is active, right, Tom? Oh, there's one question here, yeah.
Hi. So does this kind of bring us back to the same issue of kind of effectively having the same password for every website, so that that password in a sense is compromised, like every site that you have that account on is basically up for grabs so long as the key exists?
That's a great question. In other words, are we creating a really attractive target for attackers? And I think there is absolutely a danger of that. But there's a lot of things we can do, especially once we start being built into the browser, to make that much more secure than a lot of existing solutions that try to centralize access. And so the first thing we can do is all this thing of tricks that a lot of the big identity providers are doing, challenging you more when you're at a new machine that we haven't seen before, providing two-factor auth for folks that want it. All these standard tricks we will be looking at and figuring out what the right way is to do them. Once we are doing this in the browser, I think it's a much better story where we can lock this down with the password you use before you even start using your browser. But the concern you raise is not one that we think we are done handling. I think it's an ongoing one we'll have to consider as we continue to improve BrowserID. Yes?
So the design I see here is sort of has an implicit assumption of a single user for each machine.
Have you considered like how you would change this to real like multiple users that share the same machine?
So this is about multiple users sharing the same machine. We think that's a problem that exists in general when you're using most browsers today on shared machines, which is that you're logged into a whole bunch of places and you remember to log out before you leave that machine. So how we do log out in BrowserID is something we're talking quite a bit about right now. We're discussing exactly how that works, whether there's a big log out button, whether there's a, I see you smiling, Rashna, so I'm sure you have a solution for me, which I want to hear about. So, and especially being able to tell the difference between a shared machine and probably by having the user tell us, but acting differently whether it's a shared machine or not. And then also having this is kind of interesting because this is something, unlike the CAPTCHA, this is something we can do. We can ask the user once, is this a shared machine? Is this an airport terminal machine or something? And we can then communicate that information. First of all, we can take different actions based on that. And we can communicate that information to every site, so you don't have to tell every site, oh yeah, this is a shared machine, as you go. So we haven't fully fleshed that out, and we don't know exactly how logout will work in those different cases, but I think you're right that we have to be careful about that use case.
Question from Jesse on IRC. Are we putting ourselves, that is Mozilla, in the path of legal attacks against our users until we take down the temporary scaffolding?
Legal attack, is that what you said?
Yeah, I presume that's reference to legal process, people trying to give us logging orders or issuing certificates orders.
That's a good question. I think I'm not. I can say a few hypotheses, but I don't think I'm fully qualified to answer that. I'll say a few things that mitigate that situation. The keys are always stored in local storage, even with the scaffolding, right? So we don't have any keys to hand over, user keys to hand over to law enforcement authorities. We would have to change the code we deliver, steal those keys, and then give them back to law enforcement authorities. I think that's the attack we're talking about. I'm making some assumptions here. Or we would have to be forced to certify certain keys and such. And in that case, I think it's a lot easier to just go to that domain and take over their mail server and go on from there. Right. So,
do you log the public keys?
do we log the public keys? We do not intend to log the public keys. Actually, that plays into a larger question, which is what do we log? Because we have that verifier service that sites can use to check their assertions, right? So we're actually currently undergoing a pretty thorough review of our logging practices internally to actually log as little as possible while at the same time getting some basic metrics about how relying parties at least are using the system. But we're being extremely careful about the per user data we're logging. Mostly we're not logging. But to circle back to that question, I think the answer is there's always a risk of that. I don't think we're significantly increasing it with this project because we're not storing a whole bunch of user data or keys on the server. But I think this is probably a question we'll have to explore a little further with Alex.
We have another question from ILC from Tantec.
It's going to be an easy one, I'm sure.
Has anyone, you, the BrowserID team, any cool people from Mozilla, actually deployed BrowserID support on our own blogs or sites?
On our own blog? Oh, this is an easy question. Thank you, Dante. We are actually working on a couple of internal sites to deploy BrowserID internally. And interestingly, the main challenge is making sure that we scale, because we have a lot of very high traffic sites, and we've got to make sure that we can turn them on and scale right away.
Actually, you might just take a moment and
Yep.
just tell people kind of where we are in the process right now.
Please, please.
No.
Oh, you want me to take a
Yeah.
moment? Oh, the process of internal adoption?
No, just in general. Like, what's the status of BrowserID today?
Thank you. Yes, I think I did make that clear. We are still very much an experimental project. The spec will change, I hope in part based on the feedback we get today, now or in follow-up emails. The implementation will change. We are not recommending that large production sites adopt this right now. For internal projects, we're looking at the smaller sites, the newer sites within Mozilla that don't have an account system yet, so they might as well use the one that we're securing. But we're not about to flip the switch on a major multi-million user Mozilla property until we have a more stable spec, a little more feedback from the community, and a little more internal security release.
But it is live, so
it is live, so you can use it. Although, as per our terms of service, you cannot use it for financial or health data or other super high security data yet. You should not be using it for that.
Is that just as long as it's scaffolded?
For now, we'll look into exactly when we release that clause. Yeah.
My question is, if these experiments are successful, how do you see this working in a multi-browser, multi-device day in a user, how they would navigate that and how that would work?
So the way it would work in a multi-browser, multi-device setting is that you would have keys, different keys on all of your devices. Right? The browsers would all implement these simple APIs. They're simple JavaScript APIs. And we make no attempt to share secret keys across devices. Every device generates its own keys. They get certified by those providers. We will probably work within Firefox, this is a little more forward-looking than other stuff, to synchronize at least the list of identities you should have on all your devices, even if you haven't obtained keys for them yet on your mobile device, so that there's an easy way for you to go actually get those keys, go get those keys certified on that device. But we're not going to try to synchronize, at least we have no plans to try to synchronize the secret keys themselves, because that doesn't seem necessary. Does that answer the question? Cool.
What are your philosophical opinions on sort of authorization of using data from the identity providers and writing data back?
Authorization of using data from an identity. Can you give me an example?
So, for example, I use Facebook app, I authorize the Facebook page, the app has access to my profile.
Okay. My personal belief is that users should control as much as they would like of the data they release to every app that they use. The challenge there, it's very easy to say that. The challenge is building an architecture that accomplishes that in a way that most users understand and don't just click OK to. Right? That's the challenge. I don't have an answer to that exact problem, and I don't think BrowserID provides the complete answer to that problem. By design, we're trying to start very small and not step into what I think is a very complicated problem. But at the end of the day, I can certainly reduce it to the use case where if the user knows what they're doing and doesn't want data shared, then it should not be shared. That's a pretty obvious one, I think. And then it's the question of how do you get mainstream users to understand what they're sharing and how they're sharing it. So I can tell you a little bit about what we're exploring. We haven't decided this yet, but we're talking about, in that BrowserID pop-up, right? Well, I don't. In this pop-up over here, we're thinking about what additional things we can provide, signals we can provide to the user to let them know how their data might be handled at that site. We haven't agreed on that yet. This is just discussion. But maybe the privacy icons that we're working with disconnecting are icons that we might want to display here at the site advertising. Right? There is an avenue here, once we surface this login action in the browser, to inform the user better, especially on express policies, especially on things you've done in the past. What we didn't talk about, of course, is that this should tell you, oh, by the way, this is your first time logging into the site. Or you logged into the site 62 times before, you used this email address when you did. Right? All these things, once we've surfaced the login action, we can do a lot more to help the user understand what they're doing. But we haven't decided exactly what those things are yet. Yeah, please.
Can you mention Gravatar-like stuff? Like, once you have an email, you can do other things.
Right, so
there are possibilities for authenticating data either through the browser
right.
or just using the fact.
That's right. So Dan is rightly pointing out that there are different avenues we can pursue to tackle this problem as we, starting with BrowserID. One is starting with the email address to do Gravatar or WebFigure-like lookups of more data. And then the other one is delivering more information through this assertion via the browser or through other API calls via the browser. And we're looking at across the board on that front. We do think the browser has an important role to play, but we have to find the right balance between what the browser does and what the sites, what the data repository does. Yes?
We have a question from Eric Young on Twitter, on IRC. How many different implementations have tried to solve this problem over the years without gaining significant adoption? Why do you see BrowserID succeeding when so many others have failed?
How many? 42. Obviously a lot. I kid, but it's a very good question. I think the advantage we have with the solution over prior solutions is the focus on solving the simplest possible initial need with appropriate browser involvement. I think that's the and an interest in a privacy protecting approach. That, I think, are the three things that make this more, we hope, more likely to succeed than other efforts that have not. We're really fully embracing the web as our architecture for this. Obviously, it's a Mozilla. But we're also saying we don't think you can do this quite with zero browser involvement. We think that's going to make the difference. We could be wrong, but we'll see how it goes.
All right. We have another question from Nick Doty. What if I want to prove that I'm a Berkeley student without telling a site my name?
What if I want to prove that I'm a what?
A Berkeley student
Yeah.
without telling a site my name.
Right. So that, I think the question might be larger in scope than that, which is more limited disclosure questions. What if you want to disclose certain attributes but not others? We think that use case is actually probably the most often the use case you have, which is you want to disclose membership in an organization without disclosing who exactly you are. There's other use cases like disclosing that you're over 18 to solve that really problematic issue of buying alcohol online, right? Or 21. But that's the limited disclosure use cases that I think are very widespread tend to be that one, which is proof of membership in an organization without further disclosure. So this is the kind of stuff. Oh, why is that not? Oh, no, it's not displaying because I got this thing overlaid on what is otherwise a very similar slide. So, stuff we're thinking about, and this is purely a mock-up, right? It's the idea that in the BrowserID pop-up, you have the ability to generate a pseudonym right there and then. If you've already used a pseudonym at that site, you would be reminded what that pseudonym is. And we hope that identity providers like Berkeley, for example, could provide ways to generate pseudonyms that are basically random number at students.berkeley.edu and go from there. We think there are ways to solve that use case in that way. To do more complex limited disclosure, we haven't thought about how to do that yet.
All right, one more from IRC before I hand over the mic. This is from Wendy Seltzer. How easy is it to use multiple profiles with multiple different email addresses and choose amongst them on a per site/visit basis? And then, is it possible to set up multiple distinct identities linked on a single email address?
So, I think the first question has to do with how do you manage the complexity of using these different personas on many sites. And currently, we're not providing any assistance there. But we think that we can do quite a bit, of course, which is to tell you which email address you used last time, help you annotate your personas and such. I think that's how we'll do that. I don't quite understand the second part of that question. But so maybe Wendy, if you want to email us offline, I'm happy to, or on Twitter, I'm happy to answer the question publicly. Yeah.
So if a website decides to use BrowserID and then they develop a mobile app, an Android app, how would you suggest that they authorize the users?
That's a great question. So how do we do authorization from native apps, be they Android or iOS? We don't have a complete story on that yet, but we will have a story on how we do that. And it's going to vary a little bit depending on whether it's Android or iOS. At the end of the day, we want it to be the same general idea, which is proving that you own an email address and being able to do it from native apps. But that's a big problem. We want to solve it. We don't have a solution yet.
I'm in. So actually, there are preceding systems that are quite successful at an enterprise level or in federation of enterprises level. The one thing the tough nut to crack has been internet scale on sets of arbitrary size.
What has been the tough nut to crack?
The tough nut to crack is internet scale, i.e. arbitrary sets of sites that are not necessarily actively federating together.
Gotcha.
Which is what seems to be the nut you're going for here.
Yeah, I would say yeah, that's right. A little less coordination needed to get the federation going, yeah.
So given that there are deployed approaches out there, what thoughts have you given to aiding adoption of this browser-supported technique into already existing deployments of other but similar technologies?
Very honestly, we haven't spent much time discussing that, and it's probably something we want to discuss, so we should talk about it. I will note one interesting thing, which is we think that this can be useful in the enterprise setting, especially to let companies let their employees prove to external resources that they are indeed members of that company, employees of that company, without having to expose a public service to the public web, which I think for a lot of companies is a deal breaker if they have to expose yet another service outside their VPN. But I'd love to talk to you some more about that at some point. Just one more. Yeah. Oh yeah, we're over time, but go ahead.
Well, one's a comment, one's a question. The comment is that the only thing that so far have made these kind of systems successful is not the login, but what comes after, like getting access to data and resources. And if you just look at the market, every one of these efforts have completely failed because login is interesting, but it's not that interesting. Yeah. And then Facebook and Twitter are the two big examples of you want their API, you don't really want the login. That's a comment. Yeah. The question is, with regard to using email addresses, which I've been a big fan of for a long time. What I've been hearing for the past 3 years is that in a lot of systems, the people who administrate the email SMTP part of the company are not the same people who deal with HTTP. And so you're dealing with, you're crossing an authority boundary. So that if I happen to be the webmaster for a large corporation, I can go in and without the authority of the people who control the identity of the company, can now asserting different things. And so in past discussion, this has been climbing up to DNS levels, and then that has failed because DNS is not secure yet. And so it's kind of like this problem that keeps coming up whenever you talk about. So have you thought about it? Have you considered it?
So fantastic comment and fantastic question. I agree with your comment. We have to do more than login, and we will be looking at these other avenues, although we're nowhere near anything that resembles the readiness here, and even this is still an experiment. So totally agree with your comment. We're going to have to do more than login, and we're going to have to tackle the hard problem that Ilya mentioned earlier, which is how we do that in a way the user truly controls. And to your question, that's a great comment. What that probably means is that your average company with your average IT shop is not going to jump on this right away because of that separation, and I buy that. I've definitely experienced that before. Maybe we'll start with some of the larger providers that are inherently web-based, right? Where I think there's an in is in webmail, mail provided over the web. Well, there you've got the kind of juncture you need, right? You're in a web browser, and you are authenticated as that email, and you just need to make that extra little JavaScript call right there to certify that email address. So that's probably where I think our point of attack will be With folks that are already fully converted to webmail, it shouldn't be too hard. And with folks for whom webmail is kind of a side project, that might be a little harder. I think your question is right on.
So Ben, where would you direct people to go to continue to contribute to the project? Are there wikis, blogs?
Absolutely.
Where should everyone go?
So you can just go to BrowserID.org, and all the links are from there. If you want to ask us more questions about it, you can find us on the identity channel in Mozilla IRC, or you can tweet with the BrowserID hashtag, and we will generally get back to you as soon as we can, depending on how many tweets there are.
Is there a mailing list?
There is a mailing list that's linked to it from the BrowserID page. Yeah, absolutely.
All right. Well, thanks, Ben, and thanks everyone on IRC and
Yes.
here in Mountain View for what's been, I think, a really informative discussion. And we look forward to continuing to work with you guys on this topic.
Yeah, absolutely. Please send us feedback.
Great. Thanks, Ben.
So we do have another event that's